This video is brought to you by azamsharp.school, which is one of the biggest producers of iOS development videos. I mean, just check out this. 16 courses, more than 90 hours of videos, more than 90 hours of content, and it just keeps on increasing. So by the time you're watching these, it might be like 20 courses with 120 hours, all right? And now on Azam Sharp School, I do offer the annual membership, which is $249, and monthly membership, $25 a month. And what's great about these membership options is that once you sign up for these membership, you can access to all 16 courses. And check out these amazing courses: test-driven development in iOS, reactive programming combined, Swift Vapor, server-driven UI, Reality Kit, Swift Data Bootcamp. I mean, it just contains all the things that you need to become an amazing iOS developer. And I keep on adding more courses. So there are more courses that will be added later on. So this is an amazing deal. You can check out the testimonials from our existing students. And this is again one of the largest catalog for iOS development courses. So sign up for either a monthly membership or annual membership and enjoy all of these courses. Thank you so much. Let's go ahead and get back to the video. Hello and welcome to the module on concurrency. This module is going to form the basis for our next module, where we will discuss actors and isolation. We will start by understanding the concurrency, and then, just to give you a real world example, we will look at the bank account problem. That what will happen when you try to withdraw money from your bank account in a concurrent fashion, meaning at the same time. We will look at different solutions that are currently available using a serial queue dispatch, and also performing locks when you're trying to withdraw funds. And then later on, we will move on to the actors, and we will show you that how actors can easily solve this problem for you without having to think about serial queues, locks, and by just using the async and await and suspending actions. So let's go ahead and dive into concurrency. Let's go ahead and take a look at an example how the concurrency can affect your application. Now we are going to take a look at the bank account example. So let's go ahead and get started. Let's say that we have a bank account class, and we will start with a property called balance. So in order to create a bank account, you must provide a particular balance. We will simply go ahead and assign our property with the balance that you pass in the initializer. Great. Now we also have a withdraw function. You can go ahead and send in the amount that you want to withdraw. Over here, we will obviously check if the balance is greater than equal to the amount, then you can withdraw the amount. Now, when you're withdrawing the amount, we are going to assume that maybe it takes some time to withdraw the amount. Maybe it needs to do some verification or some checks that take some time. So we're going to go ahead and say processing time. And we will make sure that this is more of a random time. So sometime it might take 2 seconds, and sometime it might take 3 seconds. Sometime it might take 0 seconds. All right. Let's go ahead and also print over here something so that we know that what are we doing, what the withdraw is processing, what is the amount, and what is the processing time. And now we can go ahead and pass it to sleep. So this means that it's going to sleep or delay for that amount of time, which can be 0, 1, 2, 3. After this, we need to make sure that we are withdrawing the funds from the account. So let's go ahead and print out a message. And in order to withdraw, we will simply say balance minus equals to the amount. And it might be a good idea to even print out right at the end that we have withdrawn the money. and this is our new balance. Let's go ahead and run this application. I'm going to go ahead and create a bank account, which will be of type bank account. I can pass an initial balance, let's say 500. Perfect. And now I can go ahead and withdraw, let's say 300. If I go ahead and try to print bank account.balance, what do you think it's going to print out? Keeping in mind that when we created the bank account, it was $500 and we withdrew $300. Let's go ahead and run the application. Now, if we run the application, you will see that it's printing out all of those different things. Processing for $300 for 2 seconds. Withdrawing $300 from the account, the balance is $200, the balance is $200. So basically it comes out to be $200. Okay, looks like it's working fine. If I go ahead and simply go ahead and pass in 200, then it took us 3 seconds for the processing time and the balance is $300. So everything looks like it's working perfectly fine. But now we will implement that what happens if this is a joint account and 2 people are trying to withdraw money at the same exact time. So let's say what happens. We're going to go over here, and in order to run a concurrent queue, I'm going to use the power of dispatch queue. And in the dispatch queue, we can go ahead and pass in a label. I'm just going to call this concurrent queue. We don't really need that part. We will simply say it's going to be concurrent. Concurrent basically means that 2 particular things can happen at one time. So now we have created a concurrent queue. We can go ahead and use it. So queue.async, and inside async, we can perform bank account.withdraw. Let's say that we want to withdraw $300, right? And we will copy it again because let's say that exactly at close to that time, someone else is also withdrawing the money. And that person is trying to withdraw $500. Interesting, right? Let's go ahead and run this and see that what happens. Okay, let's go ahead and make sure that it's not giving us any errors. So that will be our first thing. Maybe I misspelled something. Let's go ahead and make sure that this line is okay. All right, so here we go. So both of these bank account withdrawals can start at the same exact moment. When the withdraw function is actually fired, then it's going to check if the balance is greater than or equal to amount. Then it's going to get some sort of a processing time. It can be 0 to 3. And it's going to sleep for that amount of seconds, and then it's going to perform a withdrawal. Now, looking at this code, can you actually guess that what will be the bank balance after both of these withdrawals have taken place? You can pause the video and you can try to calculate it, but let's go ahead and run the application. Okay, so this is something interesting going on. Processing for $300, so first one went in 2 seconds. Processing for $500, 1 second. So where is that message? It's actually right over here. So the withdrawal hasn't really happened yet. And then what actually happened is that withdrawing $500 from the amount. So the one that was second to reach over there, because it only waited for 1 second, was the first one to get withdrawn. And the balance at that time was 0. But the processing for $300 was already at this point. It was just waiting for 2 seconds. This means that at the time when you were withdrawing $300, the balance was already $500. So it just went through and it's just still waiting. And when it's still waiting, it actually tried to withdraw $300, and now the balance is negative $300, which is not good because now you have to pay overdraft fees, which might be $30 to $40 depending on your bank. So you can already see that there is an issue going on. Now, every single time that you're going to run this, it's not going to give you the same exact result. Right now it is, but if you try to run it in a loop, or if you run it, let's say, hundreds of times, then you can get different results. Sometimes it can be 300, sometimes the balance can be 0, and so on. All right. It really depends that which task went in first and what the other task was actually doing at that time. So this is definitely a real world problem, and we need to find a way to fix this. So let's go ahead and take a look at a couple of different ways that you can fix this issue. And then we will move on to the actors and see that how, when we are using the actors, we can fix these issues. So let's go ahead and see how we can fix this issue by using a different kind of dispatch queue. So now let's go ahead and see that how we can fix this problem. So the problem that we are having is that we have two bank account withdrawals happening concurrently. Concurrently simply means at the same time. So you might be withdrawing some funds, and maybe your spouse or friend might be withdrawing some funds. And since you're doing it concurrently, it's having some issue because you check the balance over here and then basically you're waiting for the processing time to happen, and the other person is also waiting for the processing time, but the other person, maybe your spouse or your friend, has already got into this particular check. So the next thing that they want to do or they have to do is to simply withdraw. And they withdraw because at the time when they got into this particular scope right here, the balance on the account was still 500. So let's see how we can fix this. The quickest way to fix this is to don't allow them to run concurrently. Instead of concurrent queues, we can go ahead and probably use serial queues. Serial queue simply means that these will be run in serial. Serial queues are also default, so it means that you don't really have to put attributes. You can already see that if I try to run the application now, it is going to run serially, meaning this particular transaction is going to happen first, and then the second transaction will be this, but this is not going to happen. Do you know why it's not going to happen? Well, it's not going to happen because the balance in your bank account after the first transaction comes out to be 200. And the balance is actually less than the transaction that you're trying to do, which is 500, which is right here. So that is not going to work. So this is called a serial queue. In serial queue, your first transaction is going to happen, and the second transaction or the second operation that you're trying to perform is just going to wait. Kind of like if you go to a bank, an actual bank, and stand in line. So the first person has to be, serviced first, and then the next person and the next person, and then finally it will be your turn. So that's one of the ways to solve this problem, that the other person has to wait before the transaction or the operation can be completed. Now this is great. Let's go ahead and take a look at another way that we can solve this issue also. In the last lecture, we resolved our banking issue by making a serial queue. Let's go ahead and take a look at another approach. So we're going to go back to using a concurrent queue, which means both of the withdrawals can take place at the same time without waiting for each other. Now we again have a problem. you can see that our bank balance is minus 300. So how can we fix this? One of the ways to fix this is to simply lock the code for making sure that no other thread can access it while it is locked. In order to create a lock, we will have to use lock, which is of type NSLock. Now, when you lock something, make sure that you're not locking it for a very long time because no other thread can access it. So just lock it, do the work, and then unlock it. We're going to go ahead and perform the lock right over here. And we will go ahead and unlock it right there. Now, if we go ahead and run it, you can see that the actual operation, which is checking for the balance, as well as deducting the amount from the balance, is happening inside the lock. This means that only one thread can go inside this code. The other thread that is supposed to do something, well, they will have to wait their turn. Make sure that you call unlock. If you don't call unlock, then everything is locked and no one can access it. And another very important thing to note about lock and unlock is you have to also make sure that if you are locking on a particular queue, like if you are working on the main thread and you perform a lock on the main thread, then make sure that when you unlock it, you're also on the main thread. If you're locking something on the background thread, then make sure that when you're unlocking it, you're on the background thread. So that is why locking and unlocking can be important, but it can also be a little bit scary because if you forget to unlock or if you lock for a very long period of time, then other operations, other threads cannot jump into that particular section of the code and execute that operation. So definitely you can use it, and you can see that we are now getting the correct result because only one thread can access the withdraw function and the other one is just waiting for the unlocking to happen. So this is another way that you can resolve this issue. Now these are all available in iOS 14 and below. Now let's go ahead and take a look and learn about actors, which was introduced in iOS 15.